classroom chemistry. It's my third video for chemical bonding. In this video, today I am going to explain you the limitations of octet rule. No doubt that the octet rule is very useful to explain the structure of the most of the organic compounds as well as the ionic compounds. And according to the octet rule in chemical bonding, each atom acquires 8 electrons to get the near electronic configuration of nearest noble gas. And according to the octet rule, there are two types of the bonding. One is the electrovalent bond and second one is the covalent bond. So for electrovalent bond, it is completely applicable for the second and third period elements. For the elements of the second and third period, the first period element lithium, barium, boron, carbon, and the second period. But for the covalent bond, it is applicable for only the second period. And for the third period, and for the elements of the third period, silicon, phosphorus, it has some exceptions. So, today I have explained the limitation. Limitation is only for the, it can be applied or it is applicable on the second period for the covalent bond. So, it is with the help of this octet rule we can explain the structure of most of the organic compounds. So now I am going to explain the exceptions of this octet rule. The first exception is the incomplete octet. Second one is the odd electron molecule, and third one is the expanded octet. So I will explain you these all one by one. First of all, I am going to explain you the incomplete octet. It means there are some compounds in which the chemical bonding is stable without having this stable octet. That is, we take these are the three compounds LiCl, BeCl2 and BF3 boron trifluoride. Now take this structure, Lewis structure of lithium and chloride. As you know, the lithium has only one electron in the lithium number is 3 and electronic configuration is 2 and 1. So the only one electron in the outermost orbit, so it is lithium, and this one is the chlorine, this one is the chlorine, and this one is the chlorine. So it has 7 electrons. It has 7 electrons. 1 electron of chlorine takes part in the sharing with the electron of the gear. So the chlorine has its complete octet, but the lithium has only 2 electrons in the outermost orbit. So here we can say that this compound has incomplete octet. Again, take the example of the second, beryllium. The atomic number of beryllium is 4. So the electronic configuration 2 and 2. So in the outermost orbit, beryllium has only 2 electrons. This is beryllium. This is the electron, beryllium, and we will Cl2. So again, you write here, this is 7 electron and this is both the chlorine have complete octet in this structure, but this beryllium has only 4 electrons that are shared electrons. So again, you should know about these are the incomplete. The third example is boron trifluoride. Now, I think that you can Now we can write this structure, Lewis structure of boron trifluoride. This is 3 electron boron. Number 5, the electronic configuration is 2 and 3. So the outermost, there are 3 electrons in the outermost orbit of the boron. So each electron of boron will share with the electrons of the 1 electron of the fluorine, and this is the 1 electron and 1 electron. So all the fluorine atoms has 8 electrons. This fluorine has 8 electrons, and this is the electron of boron, and it also has. But here the boron has only 6 electrons in this octet. So from these examples you can show that there are some compounds which have incomplete octet. Again, I am coming to the second point, the odd electron molecule. Odd electron molecule. According to octet rule, there are odd, after bonding, each atom acquires 8 electrons in the outermost orbit. So, suppose there are, this is oxygen. I have explained you in the hydrogen. It is hydrogen. You can say that this side, this is hydrogen, and this is hydrogen, and this is the octet. This one, there are 8 electrons in the octet, and there are 4 pairs. There are 4 pairs of electrons in which 2 types of the electron pair. One is bonded electron pair. You can say bonded electron pair. And second one, the electron pair which don't take part, this electron pair and this both the electron pair didn't take part in the bonding. So these electron pairs are called lone pair. So in the octet there are 2 types of the pair of electrons. One is the bonded electron and second one is the lone pair. Here I am saying that the odd electron molecule, it means you will find a molecule in which one atom has a odd electron without pair, simple letter. So you will understand by taking the example of the odd electron molecule. Take the example of nitric oxide. As you know, nitrogen, the atomic number of nitrogen is 7. So the Lewis structure, the outermost, you can write here in this way. This is the electronic structure. There are 5 electrons, 7. First cell has 2, so the second 2 and 5. So in the outermost orbit of the electron, there you will find 5 electrons. So these are the 5 electrons. Now, when oxygen reacts with, it's the oxygen, and you will have 6 electrons in the outermost orbit of oxygen. Now, by sharing of 2 electrons of each nitrogen and oxygen, you will get here complete octet of oxygen. But the oxygen here 4 and this, surely again I have mentioned this. These are the 5 electrons. 1, 2, 3 and 4 and 5. These are the 5 electrons of nitrogen. Now there are only 7 electrons in the outermost orbit of the nitrogen in compound NO. So this nitrogen had this odd electron pair. So this is called the odd electron. This is odd electron, not pair. Odd electron. The presence of odd electron shows that there is an exception in the octet tube, because according to the octet tube there should be 8 electrons in the outermost orbit of the nitrogen, as in the case of ammonia. As in the case of ammonia, these are the, this is hydrogen, this is hydrogen, this is 2, 2 and 2, and these are the 8 electrons in ammonia, in the nitrogen. But here in nitric oxide, it has only 7 electrons, and 1 electron is present as a odd electron. So again, if any question is asked with you, you can this odd electron of each, and I have taken this example. This is also NO, this is also NO, and this oxygen is bonded with double bond, this oxygen bonded with double bond, but each nitrogen has one odd electron. So when the two molecules of nitric oxide come closer to each other, these both odd electrons will take part in sharing. So the new bond will be formed between nitrogen and nitrogen. This is called the structure of N2O2, dinitrogen dioxide. It is nitric oxide. And the second one is when two molecules of the nitric oxide combines together, it's formed N2O2, and I explained the cause behind the combining of two molecules of nitric oxide. Now I am coming to the second example. Here, this is NO2, this NO2, nitrogen peroxide, or you can say nitrogen dioxide. Nitrogen dioxide also has one odd electron, so the nitrogen dioxide is an example of odd electron molecule. So again, if you go through the Lewis structure of this nitrogen dioxide, this nitrogen has 5 electrons. You can show like this. These are the 5 electrons of nitrogen, and again you will write here, this is the 6 electron of oxygen. So again, now here up to this, it is the structure of nitric oxide. Now the second oxygen will come to here, and the electron of the second oxygen atom will not take part in bonding. The nitrogen will give one electron to this. As I explained you, such type of bonds are the coordinate bonds are formed. This electron will come to this oxygen and again will share with it. So this is the octet of this oxygen. Both the electrons are of nitrogen, but here in this way. So the octet of nitrogen is incomplete. It has only one. This electron is as odd electron. So it is the structure of nitrogen dioxide, and you will write here this NO positive, this is positive, because this both the electron, this nitrogen gave one electron to this oxygen, so it is negatively charged, and this again, so when it loses one electron, so nitrogen will get one positive charge on it. So this one you can show it has only one odd electron. It has only one electron. Now the second molecule of nitrogen, when nitric oxide will come to here, so again both the nitrogen, this, so this will be the form positive, negative, positive, negative. This is called dinitrogen tetraoxide. When two molecules of nitrogen dioxide combines with each other, or they form the N2O4. So the question may be asked in your examination that why nitrogen peroxide, nitrogen dioxide or nitrogen peroxide forms dinitrogen tetroxide. So you can say that nitrogen dioxide has an odd electron. So both the nitrogen dioxide molecule come close to each other and each odd electron shares with each other to form a bond between the nitrogen and nitrogen. So the compound will be formed as N2O4. It is called the dinitrogen tetraoxide. I explained you about the second exception. Now I am coming to the third exception, that is the expanded octet. Expanded octet. As I explained you, in the elements of the third period, the octet rule cannot be applied fairly in the elements of the third period, which are the phosphorus, sulfur, and this is, they can I will tell you, this is phosphorus. Phosphorus has 5 electrons. Phosphorus has 5 electrons. These are the, so you can write here in this way, this is 5 electrons. Each electron will share with chlorine. Here is chlorine. So again this is chlorine, this is chlorine. So I have written here. So each chlorine has its octet, complete octet. But this phosphorus has, surely here you can write here 1 and 1. So there are 5 chlorine atoms which are bonded with the single atom of phosphorus. So the phosphorus has 10 electrons. Phosphorus has 10 electrons in the outermost orbit after combining with the 5 chlorine. So these are the 10 electrons. So it is called as the extended octet. It means when the number of electrons in the outermost orbits are found more than 8 electrons, then the position, that situation is called as the expanded octet. So phosphorus has 10 electrons in this. Now it is the case of sulfur hexafluoride SF6. Sulfur has 6 electrons. Sulfur has 6 electrons in the outermost orbit. So each electron will share with the chlorine atom in this way. Sorry, fluorine atom. If I have taken SF6, so fluorine atom. So each fluorine acquires 8 electrons in the outermost orbit, and this sulfur has 12 electrons. So it is the expansion of in the octet. So this sulfur has 12 electrons in the outermost orbit. Again, it is SF5 and it is PCl5. Now I will explain you. There is a compound that is IF7, iodine heptafluoride. Take the structure of iodine heptafluoride, IF7. You know that iodine has 7 electrons. Iodine has 7 electrons. You will write here 7 electrons. This 3, 5, and these are the 7 electrons. Or you can say this is iodine. How will this structure you will find? These are defined, and you can say, right, these are the 5 corners of the fluorine. Sorry, this is iodine, and these are the 5 corners of the for fluorine. The 5 corners of the pentagon of the this will acquired by the fluorine, and now one fluorine here and the second fluorine here. It is the IF7. So again I have told you, but these compounds also has the S2Cl2. Here the sulfur has 6 electrons in its outermost orbit. So when chlorine comes to here CCl, Cl, so again oxysulfur has its 8 electron, and this is the sulfur dichloride. It was sulfur dichloride. Now I am going to explain you the structure of S2S. You can take this S2S. This is the structure of H2S. This is like H2S. 8 electrons are there, and it is just like S2O. It is just like H2O. This is S2O. 2 electrons, and 8 electrons are here. Same S2S and H2O. Both the structure are same in this case. Now I am going to explain you the structure of H2SO4. The structure of H2SO4 you can write like this: O and S, O and O. So first of all you should write here in this way. You can know it is the sulfur, or it is these are the 6 electrons of sulfur. Now the 1 electron with this oxygen, and this oxygen is required here. This oxygen, and this is oxygen, 6 electron, and this 1/6 electron will share its electron with this hydrogen. So 2, and these are the 8, and these are the 8. But here this sulfur you will get here with this oxygen 2, and these are the 2, and these are the 2, or this is the structure of. So here this sulfur has 4 to 6, 10 to 12 electrons in the outermost orbit, and this IF7 has 14 electrons in the outermost orbit. So I have explained you the expanded octet. These are the 3 exceptions which I have explained you by giving their examples. Now you can say more exceptions are there as the octet rule. The fourth one exception is, you can write here that the octet rule is based on the inertness of the noble gases, that all the noble gases has 8 electrons in their outermost orbit, so they don't react, they don't form any chemical compound, so that we have created the octet rule. But now in special condition, the xenon and krypton, the xenon can form, it can form bond, it can combine with F2. This krypton, it can combine with fluorine, it is krypton. So it is also an exception. Now we have find, because the inert gas can also form the compounds like xenon difluoride and krypton fluoride. The fifth one, the structure of the compounds are not defined, cannot be defined by the octet rule. We cannot define the structure of the molecule with the help of this octet rule. And lastly, the energy of the molecule, we can't calculate the energy of the molecule with this octet rule. So these are the exceptions and the limitations of the octet rule. I have explained you. That's all for today. Now I expect your subscription, and please like it and share it. That's all for today. Thank you very much.